Welcome back to today's video. We're going to the second winter 2014-2015 update today. Going to get various things together that go into the winter forecast at the end of November. See how they're progressing at this still pretty early stage of the autumn and winter period. It's very early days, so we're just going to see how things are progressing. It's the last time we did the video a couple of weeks ago on the 7th of September. Now, before I get on with that, just want to mention the advertising. There's content ads sitting underneath the video here on my homepage at gazworthvids.com. If you click through those content ads, you'll be able to go off and read any articles that you're interested in. So have a browse through the articles, see whether you're interested in any of the articles, and if you are interested, just click through. You'll be able to go off and read those content ads. At the same time, you'll be helping to support gazworthvids.com. Thanks very much for doing that. There's some very interesting articles there. I've had a look myself, and yeah, there's some pretty interesting blogs and articles to go off and read if you would like to do that. There's also an ad sitting just above the video here on my homepage at GazworthVids. They are links to websites, and they're contextual, so they should be mainly weather websites. So if you're interested in any of those links as well, just click through and you'll be able to support GazworthVids again when you do that. Thanks so much for getting involved and helping to support the website. Just say about the websites that we're using for the video. You can find a link to just about all of them, I think, now on my links page. I'm a little bit tardy with putting some of the links on the links page, but I think most of the links that you see, most websites that you see in this video are linked to from the links page. And just really say, enjoy the video. Thanks very much for watching on this Sunday morning or Sunday afternoon, depending on when you're viewing. And the video will be kept on the website as well. So if you want to see it again, if you can't see it all in one sitting, or you want to come back and see it at some other point, don't worry, it'll be kept around GazworthVids indefinitely. Thanks so much for watching. So let's start off with the oceans first of all, and this is the latest sea surface temperature anomaly map from NOAA, NOAA in the United States. Two areas we're interesting specifically. We've got the Pacific over here, this very large body of water, and we've got the Atlantic over here. Let's deal with Pacific first. We'll see how El Nino is developing. Now, of course, I've been talking about this so much over the last few months. The El Nino is very, very, very gradually and slowly developing. It's been such a slow process to get it going, but things are now starting to happen. If we go back to the anomaly on the 1st of September, you'll see that there has been warming along the equatorial Pacific. It's this area just here that we're interested in, from Peru stretched out to Indonesia. If I go forward to this chart, which was from the 1st of September, this was the situation along the equatorial Pacific on the 1st of September. So sea surface temperature anomalies, if we go back, I think you see there has been a clear warming trend along the equatorial Pacific over the past 2 or 3 weeks. Now, it isn't an El Nino still. We haven't reached the required temperature threshold for that yet. It's got to warm up more, and of course, to get an El Nino actually designated, it's got to be specifically in this central part of the ENSO region, the equatorial Pacific. It's also got to be over 5 tri-monthly periods. So it could be that this never really gets designated. I think it will reach the temperature threshold, but if it doesn't go on over the 5 tri-monthly periods, then it may never actually be called. But of course, just because it isn't designated as now Nino has gone over 5 tri-monthly periods doesn't mean it isn't impactful. Quite interesting how this cold body of water going back towards the coast of Chile is shrinking. I spoke about this on the last video on the 7th of September. If we go forward again, this was the situation on the 1st of September in terms of this cold water stretched out from Chile going up towards the equatorial Pacific. If we go back to the most recent chart, you see that that water is shrinking all the time and dying back towards the Chilean coast. That's important because that water has actually been putting this central part of the equatorial Pacific under some pressure, really. It's been sort of fighting against the warm water rising up to the top. So I think the fact that we begin to push that cold water away and weakening it off is also starting to allow this warm water to develop along the or in the central part of the equatorial Pacific. What we're looking at, remember, is a Modoki El Nino, a central based El Nino. So essentially for a cold winter anyway, we're looking for this area just here in the central part of the equatorial Pacific, looking for that area there to be cooler, warmer, sorry, than this area just here. This area wants to be cooler off the Chilean coast. If it's cooler there and warmer here, it's a Modoki or a Mediki or a central base El Nino, however you want to pronounce it. And a central base El Nino, I talked about this in the first winter update, but I did on the 7th of September. A central based El Nino does feed back, or seems to feed back more often than not, into very cold winters in Europe, and sometimes that cold can get into the British Isles as well. If you want to know more about that, I won't show you the charts on that for this video because we already did it last time, but if you want to know more about that, just check that out on the winter updates page and get that off the seasonal page here again as well, as you can see how a central based El Nino very much is impactful in terms of the colder winters for Europe. Now, also sticking with the Pacific Ocean first, and we can see that we've still got this very warm water up here off the coast of Alaska and Canada and northwestern America. We had that last winter, and that's quite important. It was quite important last winter, I think, because it promotes, when you've got water there, a warm water there, it promotes high pressure to be in this part of the Pacific. It's quite an unusual place to get warm water, but when you get it there, it's helping to promote high pressure, and that in turn last winter helped to promote a ridge. I can't show you this because the United States is coloured black on this chart, but it helped to promote a trough across eastern and northern and northeast parts of the United States. A cold trough was promoted by this ridge sitting up here off the northwestern coast of America. That cold trough plunged cold air down into the States, and then once that cold air went over the warm water of the Atlantic Ocean, it exploded cyclogenesis and the jet stream in the Atlantic, and that did play a part in producing the very stormy and wet winter that we had in the United Kingdom last winter. Now, I think we're going to have to put up with this warm water up here again, so even from this starting point, it probably does offset the chance of a cold winter to some degree with this warm water up here. But just because that's what happened last winter doesn't necessarily mean that's what will happen this winter. If we can set up northern blocking around Greenland, then with an active Atlantic, all that's going to happen is that's going to push the jet stream further southwards, and instead of running it through Scotland, we'll run it through Spain, and the results will still be the same. Still be a very stormy Atlantic winter. It's just that the jet stream will be a few thousand miles further south, and we will be on the cold side of the jet. So we've got to, I think we're going to have to put up with quite an active Atlantic this winter because we got this ridge up here, but it doesn't necessarily mean it's curtains for a cold winter. It will depend whether we can get blocking going over Greenland, and that will be decided by other factors. So let's have a look at the Atlantic Ocean, and quite interesting, we've got this cold water just here in the central part of the Atlantic. It's quite warm around that cold water. That is not a tripole. To get a tripole, we would need to stretch that cold water back to there and have it in that sort of a region with warm above it up here and then very warm down here. So it's not a tripole. It is interesting though that the Atlantic has turned quite cold in that central part of the ocean. I'm not sure it's really going to be all that impactful. I would expect that to very quickly be replaced, or it could expand. It may turn into a tripole, but I would expect what's going to happen is that the warm water will get rid of that, because we're in the warm phase of the Atlantic multi-decadal oscillation. So the Atlantic is set up to be quite warm really at the moment, so I'm not sure that cold water is going to last all that long or be all that impactful. But should it develop further and push further back towards the eastern seaboard of the States, then we could start to set a tripole up, because it's still pretty warm around that cold water across much of the Atlantic Ocean. Just because you're in the warm phase of the AMO doesn't necessarily mean that you're going to have a warm Atlantic all the time, because technically we're in the cold phase. The PPDO, the Pacific, should be quite cold, but it's very warm at the moment, and it should be particularly cold in this area just here, where it is particularly warm. So we're sort of going against the long-term trend at the moment in terms of what's happening in the Pacific, and that could happen in the Atlantic as well. We may turn it even cold in the Atlantic. Have to wait and see how that goes. But in terms of what's happening in the Atlantic, I'm not sure that's particularly impactful for our winter prospects. What's happening in the Pacific could potentially be quite impactful if we can get this El Nino going in the central part of the Pacific Ocean. Watch this space. Now, these are the Southern Oscillation daily, provisional daily indexes, just to show you that we are gradually progressing into this El Nino. I think it's only going to be a weak El Nino. It's not going to be a strong, or probably not even a moderate El Nino. I think it's just going to be like a borderline neutral to weak El Nino, something like that. But we are progressing into it. When the Southern Oscillation is negative, then it's telling us that the atmosphere in the Pacific is coupling up with the oceans, essentially, and allowing this El Nino to get going. So you see that since the last video on the 7th of September, every day has posted a negative return. For instance, the 9th was at minus 23.59, the 10th was at minus 12.95, the 15th at minus 13, the 19th at minus 10, and so on. Now it just wax away in terms of how strong or how weak these daily returns are in terms of their negativity. But every single day is negative since we did the last update on the 7th of September, so it's the past 2 weeks we've been posting negative Southern Oscillation indexes, meaning that the atmosphere and the oceans are reflecting one another, not fighting against one another, they're reflecting each other, and the El Nino is very slowly, gradually getting going. I'll keep you posted on it over the next few updates. Now, this is the solar disk on our side of the disk today from solarham.net, and solar activity today is officially designated as being at very low levels. So we're very low in terms of solar activity today, but we're still getting little spikes upwards with this solar cycle. This graph here is showing us solar cycle 24, which is the cycle we're currently in just here, compared to solar cycle 23, which is the last cycle. And quite honestly, the first thing that's very obvious is that it's a much weaker solar cycle that we're currently in compared to the last solar cycle. Nevertheless, we're spiking at times. We had the first peak of solar maximum of solar cycle 24 at the end of 2011. We had the second peak at the start of 2014, January, February 2014. We got the second peak of solar maximum. I don't think we'll get back to that sort of level of solar activity again now for this solar cycle. Never say never, it's a very strange cycle. We will get further peaks, I think, over the next year or two, but I would suspect we won't get as far back or as far up as that second peak that we had at the start of 2014. Nevertheless, we are getting spikes up, and this latest graph was generated from NASA this month in September. It's reflecting the activity up to August, and if I go forward and show you the graph that was reflecting activity up to July, you see that we did have that little spike just there, picking up to the end of July. Going backwards, having a look at this graph, I think you see that, yes, we have spiked up ever so slightly, not much in it, but ever so slightly more activity in August compared to July. So the sun is still sort of churning away. It isn't going down into solar minimum yet. It will over the next 2 or 3 years, but it's not going to be a linear process. We're still going to get spikes upwards, whilst the general trend, as you can see from this line just here, or these lines just here, the general trend will be downwards, but there will be further spikes along the way. We had one of those in August, not a great deal different compared to July, but it's just telling us that the sun is still relatively active. We're coming off the solar maximum, albeit it's still generating sunspots. It's still relatively active. When you come off solar maximum, it's not a great time really to get cold winters coming out of a solar maximum. Now, the fact that this solar cycle is so much weaker than most cycles in the 20th century, actually, it means that we do have the chance of even it around this solar maximum period, we do have the chance of getting some colder winters, but it's not a great time really, is what I'm trying to get across. Expecting colder winters. The time that's best really in terms of solar cycles is around solar minimum and 2 or 3 years after solar minimum. So the next chart we're going to look at when the page clicks over, my computer has started running relatively slowly. The next chart we're going to look at, there we go, is for hurricane activity. This is the hurricane season for Wikipedia for 2014. This is important. I'd like to look at the hurricane season because what hurricanes are doing is transporting warmth from the tropics up in towards the polar regions, sort of dumping warmth in the polar regions, if you like. It's one of the ways that the Earth sort of regulates its temperature. When you get a lot of hurricanes dumping a lot of warmth into the North Pole, it can feed back later on into winter, into blocking. Now, we didn't have hardly any hurricanes at all last year. We've got some, or we've had some so far for this hurricane season. So far we've had 5 storms in total, 4 hurricanes and 1 major hurricane, category 3 or above. So things are a little bit more active this year compared to last year, but you would by no means say this is a very active season. It isn't. Nevertheless, more hurricanes are taking place this year, and it's still quite early in the season. We've got October into November to go as well, but I don't think it's going to be a big hurricane season by any means. It's not going to be a 2012 or say a 1995. It's not going to be a really active one this year, but there will be more than last year. Now, in the easterly phase of the QBO, which is signalled by these white areas just here, when you're in an easterly phase of the quasi-biennial oscillation, it tells you that the zonal westerlies around the northern hemisphere are weakening. We're in a weaker phase. When you're in a westerly phase of the QBO, which is indicated by these grey areas just here, when you're in a westerly phase, then the zonal westerlies are strengthening basically across the northern hemisphere. So westerly phase QBOs tend to coincide with milder winters. Easterly phase QBOs tend to coincide with a chance of colder winter, but it's not as straightforward as that, because very often, or not very often, but quite often in an easterly QBO you'll still get mild winters. So for instance, let's have a look. There's this one just here, 98-99 was an easterly QBO, but it was a mild winter. 2007-2008 was an easterly QBO and it was a mild winter. And we can have a look at perhaps one more, shall we? 93-94 was an easterly QBO but was a mild winter. Now, you do get cold winters as well coinciding with the easterly QBO, and your chance of a cold winter is greater with an easterly QBO, but it's just not a guarantee. So 2009-2010 easterly QBO, we had a cold winter, and 2012-2013 easterly QBO and a cold winter. So it increases our chance for QBO of getting a cold winter. It's by no means a guarantee. I'll have a look at this in more in-depth, I think, in a future update. What I want to do is look at the QBO set against ENSO El Nino, because I think that could be perhaps a key to some of these years that are easterly QBOs but are posting milder winter. So we'll do that in another update. But we are in an easterly, or we will be in an easterly QBO. We're going into the easterly QBO. It'll be an easterly QBO winter. So it increases but doesn't guarantee our chance of a colder than average winter. Siberian snow cover and Arctic sea ice finally, and this is the latest image from NOAA again for the Siberian plain. We've got some snow appearing now across northeastern parts of Siberia. Excuse me, not a great deal to be honest. There's not a huge amount going on across the Siberian plain. We're perhaps a little bit below average, in fact, in terms of the snow cover for this stage of year. Perhaps I expect a little bit more than this. But there's not a great deal in it. It's very early days anyway. This becomes much more impactful through October. It's how quickly we can fill this up, and we will fill all of this up eventually. Thousands of miles of snow will appear across the Siberian plain all the way back to western Russia through October into the start of November. It's how quickly that happens that's going to be important. So that will become much more important to look at as we get through to October and the start of November. We really will start concentrating on that next month. In terms of the sea ice loss, we have lost quite a bit, but it's not been too bad a year. If we go through to 2012, that's how much ice we lost in 2012, a catastrophic melt season, that one. We've not done as bad as that this year. There's a lot more ice this year compared to 2012. excuse me again. What's important about that, of course, is that whilst it's quite controversial, there is some evidence that the more ice you lose, the greater your chance of blocking. So what happened in 2012 is that we lost a lot of ice, and we filled the Siberian Plain up very, very quickly with snow through October. And when we put the two together, that probably helped to generate our colder winter for 2012 and 2013. Now, we haven't had such a catastrophic melt season as 2012 this year. Nevertheless, we've lost quite a bit of ice. We are below the last sort of decentish year, which is this line just here, this blue line, 2006. That's the last sort of year that we had a decent sort of near normal melt season in the Arctic. We're below that on this black line just here, and we're sort of very close to a cluster of these years just here, which are years such as 2009, 2010. What other years are in there? I think we've got 2013 in there as well. We aren't in a death spiral year such as these lines just here, which are indicating 2012. I showed you that at the start, 2011, 2007 as well. Those were catastrophic sort of melt season years. We're not as bad as that. We're sort of in a cluster with 2009, 2010 and 2013, but we're below 2006, which was the last good year. I'm not sure that really has a great deal of impact on our winter prospects one way or another. 2006 was a mild winter, but these clustered years that we're close to, I mean 2013 of course mild winter, but we've also got 2009, 2010 in there, and they were cold winters, and we're sort of on a par with those years. So I'm not sure it's tremendously impactful what's going on there, but of course it's good news that we haven't had a death spiral. Speculation, but by now the Arctic sea ice will more or less be gone, let's face it, so it's pretty good. Whatever it means for our winter prospects, it's pretty good. I think we'll all agree that the Arctic is sort of coming back from what happened in 2012. But again, the El Nino this year, it'll be interesting to see how much ice we lose next year, because that feeds back, of course, when you warm the Earth's temperature. That's all circulated around the globe in the end via the ocean currents, and it'll be interesting to see how much ice we may lose from the North Pole next summer and autumn. So I wouldn't necessarily say that things are looking up for the Arctic. It's a very long-term, talking about very long-term trends, so I've got to wait and see how that develops. Anyway, I've waffled on far too long. The basic upshot is that things are progressing very slowly in terms of the El Nino. Everything else is more or less about where you'd expect it to be for this very early stage leading up to the winter. These updates will get much more interesting, particularly in terms of the Siberian snow cover, as we get through into next month. But I hope you found the video interesting anyway, on this Sunday morning or afternoon, depending on when you're watching it. Thanks for watching the video. Next week we'll be doing the first seasonal model roundup, and get all the seasonal models together and see what they have got to say for the winter. I'm sure they'll make for very interesting viewing. And the next update, getting all of this stuff together, will be in a couple of weeks' time, so come back for that. And that's all for now. Thanks for watching.